In this video, I'm going to be explaining what ratios are and then how we can use them to find some unknown measures. There are a few basic unit conversions that we hopefully already know, but in case we don't, here they are. There are 3 feet in every yard, there are 12 inches in every foot, and there are 100 centimeters in every meter. So hopefully we already know those. A lot of times you may be given a unit conversion to use in a problem, and other times you won't be. So it's always nice to know some of them already. What is a ratio? Well, a ratio is a way of comparing two or more things. It's a relationship between them. How do they compare? So for instance, if I wanted to compare yards to feet, that would be a 1-to-3 ratio or a 1-to-3 relationship. We have lots of examples in real life of ratios. Percents are actually ratios. It's how much we have out of 100. There are ratio scales listed on maps or in models or diagrams telling you what the size of that model or map is compared to the real life value, either length or size. We have ratios that we use in recipes when we want to double a recipe or triple a recipe. And then in general, anything that we compare is a ratio. So we can compare parts of something to parts of something else. Or we can compare parts of a total amount of something or parts of a whole. So lots of different ways we can use ratios in real life. When we want to represent a ratio, we can actually represent it or write it in 3 different ways. So we'll use this example. We're going to compare 2 basketballs to 5 soccer balls. We're just going to compare the number of balls to each other. So we can do that 3 different ways. We can write it in a fraction form. I can say that the comparison or relationship between basketballs to soccer balls is 2-to-5 in fraction form. We could take that fraction bar and instead write the word 2 and do the exact same comparison. It's a 2-to-5, and we can say it just in word form. Or we can change that word TO to a colon, and then we got the colon form. So all of these are equal ratios, just 3 different ways to describe it. Another thing we need to be able to do is simplify a ratio. We always want to write ratios in a simplified form or a reduced form. And so we can use these 3 steps to kind of help us do it. Whenever possible, you always want to convert your ratio to the same units. So for example, here I'm comparing feet to inches. My first step is going to either write them both in feet or both in inches, whichever helps me more. If that's not possible, then it's not necessary to do. Like in this last example, there's no way to make basketballs soccer balls. So we can't make them the same unit or the same thing. So we just simply write the simplified number ratio, 2-to-5. If you have your number ratio, always reduce those numbers. You could reduce it in its fraction form if that feels more familiar. But really, you're just dividing by a greatest common factor to reduce. So if you can do that without a fraction form, that's cool too. And then you always want to rewrite your final ratio, your simplified ratio, in the same form it was given. So if I'm given a ratio in fraction form, after I simplify, I got to keep it in fraction form. Or if I'm given a ratio in word form, I always want to keep my simplified ratio, my final answer, in word form as well. So let's practice these 3 steps. So here we're given a ratio 8-to-12 in fraction form. We know how to reduce fractions by factoring out the greatest common factor. The biggest number that goes into 8 and 12 is 4. So 4 times 2 is 8 and 4 times 3 is 12. If I just reduce or get rid of the 4, I'm left with 2/3, which is the same thing you get if you divide top and bottom by the greatest common factor. If I divide 8 by 4, I get 2. If I divide 12 by 4, I get 3. So a lot of different ways to reduce. If you know how to reduce, just choose the method that you're most familiar with and most comfortable with. Here's an example in word form, and we're given 2 different units. So my first step is to make sure I rewrite my ratio in the same amount of units. And it doesn't matter which units you convert them to. If I wanted to convert these to feet, I could say 2 feet to 1 foot, and then I would be done. It's a 2-to-1 relationship. If I go a slightly longer route and convert them to inches, 2 feet is 24 inches. There's 12 inches in each foot, so if I double that, I get 24 inches. And now if I divide these two numbers by the greatest common factor, 12 is the biggest number that goes into both of them. 24 divided by 12 is 2, and 12 divided by 12 is 1. Then I can get my simplified ratio comparison 2 to 1. So either way you do it, you should end up with the ratio 2 to 1. Since we have the same units, we don't have to include them in our final answer. All right, one more time. Let's do another one similarly, except this time it's in colon form. So we're going to make sure that we rewrite our final answer also in colon form. We have yards compared to feet. Well, 9 feet is the same as 3 yards. There's 3 feet in each yard. So if I divide this by 3 feet, I get 3 yards. So I could say 2 to 3 and be done. Or we could convert it to feet. There are 3 feet in each yard, so if I double that, 2 yards is 6 feet. And now I can divide these by their greatest common factor. 3 is the biggest number that goes into both of these numbers, so if I divide both of them by 3, I get my reduced ratio. So 6 divided by 3 is 2, 9 divided by 3 is 3. So comparing 2 yards to 9 feet is a 2 to 3 ratio. Another way to reduce fractions or reduce ratios is to come up with what's called a prime factor list. So if you can create a factor tree and break a number down into all of its prime factors, and if we do that on top and bottom, then we can cancel common factors that we see on top and bottom. So it's a little bit more of a visual way to do it, as long as you can factor a number into all of its prime factors. So if I do 72 divided by 2, that's 36 times 2. If I divide that by 2, I have 18 times 2. If I divide that by 2, I have 9 times 2. And if I divide that by 3, I have 3 times 3. So I broke 72 down into 3 times 3 times 2 times 2 times 2. That is 72. You can do the same thing with 156. Break it all the way down into a bunch of prime numbers, a bunch of prime factors. So if I divide it by 2, that is 78. If I divide that by 2, that's 39. If I divide that by 3, that's 13 times 3. So here are all my prime number factors. Now I can just compare the list and cancel or cross off any of the common factors. So I can get rid of this pair of 3s, this pair of 2s, and this pair of 2s. So that leaves 3 times 2 on top, which is 6, and just 13 by itself on the bottom. So my reduced fraction form is 6/13. You could do it that way. You could also divide by the greatest common factor if you know what it is. So as it turns out, 3 times 2 times 2 is the greatest common factor. That's 12. So if you divided top and bottom by 12, you would have got 6/13 much faster. All right, one more time. Let's do some algebraic expressions and reduce those. Just make sure we remember how to do that. Again, we're looking for common factors that we can cancel. So the biggest number that goes into both of these, you can rewrite it in fraction form if that helps, or you can just think, what is the biggest number that goes into 3x and 27xy? Well, 3 goes into both of the numbers, x goes into both of the terms, so 3x must be the greatest common factor. I can divide both of these by 3x and get my simplified form. So on the left, 3x divided by 3x leaves me with 1. 27xy divided by 3x leaves me with 9y. So 3 goes into 27 9 times. X's are common factors, they just go away, and we're left with that y. So the final simplified ratio of these terms is 1 to 9y. So what can we do with ratios? Well, we talked about a lot of examples. Here is one geometric example that we can use. The measures of two complementary angles are in the ratio 4 to 5. So these two angles are in a comparison of 4 to 5. We can find the measure of each angle using this ratio. As long as we know what complementary angles are, we can figure this out. Complementary angles are two angles that add up to 90. Well, first let's figure out how many parts we have 90 degrees broken up into. 4 and 5 parts, so a total of 9 parts. So you could say 9 times the number of parts is 90, or 4 parts plus 5 parts is 9 parts, and that equals 90. Solve for x and you get x is 10, and then you can just plug it back in. This is 4 times my parts, so 4 times 10 is 40, and 5 times 10 is 50. They add up to 90. those are the measurements of the angles.